Hey everybody, I wanted to make a helpful video for the class. I've had quite a few questions in regards to the Week 13 practice assignment. So I want to make sure I kind of go over this so you know what I'm looking for when it comes to filling out the table at the end. Now, most students tend to feel pretty confident with part 1, so I'm not necessarily going to go over that. But part 2 tends to be the one that gives students a little run for their money. So now the first thing that we have to do when it comes to doing this part of the assignment is looking at the new vocabulary words that are bolded. So for example, incomplete reaction, which is a chemical reaction that doesn't always run to completion. So an example of this would be a reversible reaction. It's not running to completion, it's moving forward and backward. Completion would be where all of the reactants are used to form all new products and there's no reactants left once the equation is done. And it has to take place in the same container. A closed system is just describing where the reaction's happening. So for example, if we have a beaker, which is a glass container that we use in chemistry, and we put reactants together in the beaker, and then the reaction happens, and let's say it's just forming a solid and a new solution, for example. As long as the products and the reactants stay within the beaker, that's a closed system. Now, let's say we put baking soda and vinegar together in a beaker. If we put those together, it bubbles really, really violently, and it gives off gas. The gas is allowed to escape the top of the beaker if we don't put anything above it, so that would be an example of a system that is not closed. So again, a closed system has to contain all of the reactants and products, meaning the mass is not going to change for that system. We talked about a reversible reaction, meaning a reaction can move forward to products or reverse back to reactants, and that's noted by that double arrow where you have an arrow head to the right and an arrow head to the left. Equal rates of forward and reverse reaction, this is equilibrium. So remember, it has to do with rates or the speed at which this is happening, not the amounts, the speed. Constancy of properties, there's no net change in the amounts of reactants and products. And that one has to do with the total amount of reactants and products. It's not dealing with rates, it just has to do with how much reactants and products you have. Now, with this one, once we're in equilibrium, we can have constancy of properties because ultimately the amounts of reactants and products might not be equal, but they're not going to change. You're always going to have the amount of reactants and products when your rates are the same and not moving. And then dynamic process means that something is changing. If we were to say static, that means something's staying in place. Dynamic means it's moving. So if the system is changing continuously, a reversible reaction would be a great example of this. You have something forming products and reactants, and the system is continuously changing or moving. Now, if we look at those vocab words and then put this into an example, sometimes it's easy to look at outside examples or analogies to make sense of things that otherwise might be more confusing. So for example, I'll kind of walk through this escalator piece. Now, if we're talking about an escalator in terms of an incomplete reaction, it would depend on what part of the picture we're talking about. An escalator can be an example of an incomplete reaction if you have people going up and coming down. Because again, it's not going all to completion. You still have people going towards the bottom level and someone going towards the top level. So that would be a good example of an incomplete reaction. Now, it's also a very good example of a reversible reaction because again, you have some people that are going up towards a higher level and other people that are coming down. So they're moving in opposite directions. So that would be a very good example of a reversible reaction as well. Now, if we talk about a closed system, it would depend on where the escalator is located. If, let's say, the mall was locked down and people couldn't leave, that would be a closed system. However, if people are allowed to leave the store and go home and come in and out of the mall, that would not be a closed system because you're losing people to the environment. So it's not actually staying within the system that we're actually looking at. Equal rates of forward and backward. If we have an equal rate of people going up as we have going down, that could very much be possible. We know that we could have constancy of properties if we have equal rates of people going up and going down. And then we know this is also a dynamic process because people are still moving. So that's an example of how to look at this and use what we've learned when it comes to those terms in order to help you with analogies. So now when you go down here, here is an image, and it would involve filling up and removing dirt from a hole. And it talks about the size of the shovel and taking dirt out and once putting dirt back in. Now, as you scroll down here, you'll notice that you have an example reaction. We have the escalator analogy that I went over for here, and then the shovel one. Your gray analogy is for the discussion piece, so you don't have to do this for the practice problem, but you do want to do these 3 columns here. Now, an example reaction, if you want, you could use the one given right here, but it's entirely up to you, okay? So that's a little bit of what to expect for the week 13 practice. If you find that you're still confused and have any questions, make sure to email me and I can help you with that. Otherwise, you can always email me questions or text me questions as well.